Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Naufal Aulia Amanullah. I am electrical engineering student batch 2019 and today I will present to you about introduction to wireless communication. Okay, as we can see here in the picture, these buildings, vehicles and smartphones are connected and communicate with each other. It represents how people will imagine the network in the future to be. IoT or Internet of Things are involved in the future wireless network. The future wireless network aims ubiquitous wireless communication to every single object that can transmit and receive signals. We can create a smart home environment with a smart home furniture where we can turn on or turn off lamps from our smartphone and then checking our CCTV from our smartphone and etc. Then we can also create these smart cities where all buildings can communicate to each other. Even inside the buildings, they have devices connected to each other. And then, this building also can be connected to a network of the vehicles here. Okay. We realize that there are various challenges in implementing wireless communication. The challenges appear in terms of the network or radio, and then on device or SoC or system on chip. I will start challenges in terms of the network. Okay, the first one is GPB, gigabit per second data rates with no errors. It is essential to provide a high-level data rate with fewer error percentage since people enjoy the high-definition video, which requires a higher data rate. So a higher quality file means a higher data rate. And then the second one is energy efficiency. Nowadays, people use more than one telecommunication devices and it needs to be powered by an electricity, which will lead to increasing usage in electricity resources. Thus, the device needs to be more efficient, which is better battery and etc. And then the third one is scarce or bifurcated spectrum. The spectrum wave used for the wireless communication is limited, and each telecommunication technology has its design for a dedicated spectrum. For example, like FM works in 88 megahertz until 108 megahertz. And 2G it is works in 900 megahertz, and 5G works in 3.3 until 3.8 gigahertz. Okay. And then the fourth one is reliability and coverage. Reliability means the ability of the system to provide a good service. For example, how to provide and maintain good data rates, low latency, and etc. And coverage means somehow the network technologies should provide a wider area or a whole country. A wider coverage area can gain more users. And then the fifth one is heterogeneous networks. A heterogeneous networks means that there are different types of network technologies such as 2G, 3G, 4G, 5G, Wi-Fi, Bluetooth, and etc. that needs to work seamlessly in one place. Okay, the sixth one is seamless internetwork handoff. Seamless internetwork handoff means that sending service to another BTS or base transceiver station. It is essential so that the user can call a person from areas far away seamlessly without interruption. This is the challenge that happens since you are disconnected from BTS in your region and redirected to another BTS near the destination area. Then let's move on to the challenges in terms of device or SoC or system on a chip. As you can see here, these are these are the main components of the smartphone. There are Bluetooth module, memory module, CPU, radio module, GPS module, Wi-Fi module, and etc. The smartphone must have a good performance in order to support advanced technology and get a good user experience. And then the second one is complexity. Things inside our smartphone are getting more complicated since the size of components are getting small as time goes by to give a compact smartphone design with advanced technology. And then the third one is size is the challenges in size, power, cost, and energy. And then the fourth one is high frequencies or millimeter waves. Nowadays, people want to get a higher data rate and it can only be provided by high frequency. So the millimeter waves deliver the high frequency. So yeah, this is important things. And then the fifth one is multiple antennas. To deliver high frequency, it needs multiple antenna configuration. In current generation smartphones, there are 2 times 2 antennas configurations. It means that there are 4 antennas inside our smartphone. And then the sixth one is multi-radio integration. It means that multi-work frequency. Our smartphone can be used for radio, Wi-Fi, GPS, and etc. And then the last one is coexistence. Our smartphone still needs to have coexistence with the older technology. For example, our smartphone is 4G based network. It should be able to use 2G and 3G networks. Okay, so here we can see how mobile data growth is related to spectrum and why spectrum efficiency is extremely important. So we can see that within 5 years, from 2009 until 2014, the traffic grew from 100% to 1250% here. We can see also here in the bottom the amount of spectrum that can be allocated. So from 2009 to 2014, due to this large amount of mobile data growth, the amount of there is a spectrum deficit. In 2009, we have 377 megahertz available for crossover system mobile devices, but in 2014, we had a massive deficit of negative 275. So yeah, this is another challenge in this era. The government should be the one responsible to manage the airwaves so that high data rates are able to pass through with ease. Okay, this is the software defined or SD radio. SD radio can be one of the solutions to the listed problems above. This technology makes the radio not only for one module but can be seen as a software. The DSP or digital signal processor can be programmed so that it can use for any technology, for example like 3G, 4G, 5G, and etc. With this technology, we can generate a high spectrum bandwidth of the signal. So, okay, this is the Shannon limit. Shannon limit is something that people develop these networks needs to know because it can determine the upper boundaries of the system. So what the Shannon limit is, it shows our network capacity. In other words, it is the amount of information that can be transferred in this network. In this formula, we can see the bandwidth. This is the bandwidth. This is S is transmission power. And then N is noise. S per N also can be as SNR. It means signal to noise ratio. So when high power is used, we can send or receive more information and vice versa. When the bandwidth is large, more information can be placed and vice versa. So thanks to the Shannon limit theorem, we can develop the current communication technology, and this formula is still useful until today, even to 5G and beyond. Now, we will talk about the current and next generation wireless systems. Today, it is common for a device to be able to cater to 4G or LTE cellular system. Maybe in 10 years' time, 5G and 6G will be the most common cellular system. In certain countries, the millimeter waves, massive MIMO or multi-input and multi-output system have been applied, as well as satellite systems such as Starlink. Then there is a ZigBee, which is communication module that usually used in Arduino or Raspberry Pi. Then there's a Bluetooth that we often use for short-range communication. Then wireless systems that might appear in the near future include 5 until 7G Wi-Fi system as well as ad hoc and cognitive radio networks. And then energy harvesting system are also an emerging system in which the energy is not sourced from a battery but sourced by harvesting through a mechanical system such as a turbine system to generate electricity for the wireless communication system. An unorthodox example of an emerging system includes a power source from chemical or molecular communication system, which indeed still has room for development and innovation. So that's all for me. From me. Thank you for your attention and goodbye.